All right. So this is our Etherpad. And hopefully people have signed in. The helpers can add the link there. You can assign yourself a color if you want, and it will highlight when you type. So my color is this. Right. But if you
fellow helpers, there's a Mac question in the chat.
Okay. Can somebody, Christian or Lee, hopefully
I'm the
grab that?
Windows Linux person.
Yeah, I was writing back, but the question is which R to download. I think the most recent version on there. I just want to clarify. You'll need R and RStudio. I'll make sure that the links are in the Etherpad.
Okay, can people see that? So yeah, this is a data carpentry version of Intro to R. And Carpentries is this like umbrella group that teaches data and coding kind of foundational skills. And we're a member here at UCLA, and Lee, me, Christian, and Jamie are all instructors that are certified to teach this. And data carpentry is a special carpentry. We're teaching the social science version of this lesson. So one of the questions that always comes up is like, what is R and what is RStudio? Because we're going to use RStudio and we're using R in this workshop. So R, you can think of it as the engine, like the thing that runs R. And then RStudio is a editor or a ID, often called an integrated development environment. It's jargon. It means like it's an editor for you editing R, and then you control a lot of the aspects of how R runs. It also will let us preview our graphics when we create those. It will let us keep track of like the internals of what's happening in R. So one of the big questions is why do you want to learn this thing? It doesn't, R isn't like Excel. It's not like you're doing a bunch of, menu driven stuff where you're clicking and doing this macro, doing another thing, undoing, redoing. You don't do any of that in R. And that's a good thing because you learn to do it in code. So then it becomes reproducible. So you don't have to remember all those steps you do in a menu-based system. If you have it set up in code, then you can run the code and we'll do that thing over again. That also makes for really good reproducible research. So basically you can, it will make your research more transparent, and it would make it more credible in a lot of ways because it is in code and you can run that code and reproduce your results if somebody asks you. And that could be you in 3 weeks because you don't know what you did, previously 3 weeks. So a lot of this is about developing good practices of doing when you do your analysis. R has over 15,000 these third-party packages. It covers every discipline you can think of, like area like text mining, the hard sciences, biosciences, anything you can think of. R has a community that is working in that discipline. You can work with all data of all sizes, excuse me. So you can work with data locally, like a smaller data set. You have local, you can connect to a remote database. You can work with data that is arbitrarily large by using tools in R to kind of work around that. So it's all different types of formats. It's many more than just kind of spreadsheet or Excel type objects. You can work with text. You can work with like science formats that are designed for, like high density kind of stuff. So R has a real wide range of things that you work with. And it produces, one of the things that attracts me to R, produces high quality graphics. So if you're writing a paper, and you need to make a really pretty graphic, or a plot, R is a really good choice for that. And the biggest thing to me is this really welcoming community. It's a very open community, warm, welcome. There's all these types of communities around LA. Before pre-COVID, I would go to a lot of the R meetups. I've done less of that since it's moved to Zoom, and since I work on Zoom all day, I don't go to as many meetups as I used to. But there's a vibrant community around LA. There's a group called R Ladies that is more geared to making R more welcoming and accessible to women. And there's a R meetup that is monthly. There's just all kinds of communities around R that it makes it really kind of inviting to join. And it's free and open source and cross-platform. So it runs on your Windows, it can run in the cloud, it can run on a Mac, it can run on Linux. So it's like any tool you use, R works pretty well. So one question I have for you, why do you want to learn R? And if you feel like it, if you could go ahead and share in chat or come off mic just for a second. Are there any reasons you specifically want to learn R and why you're here? Prepare for econ upper div class, all right? Because people talk a lot about it. Practical skills, technical skills. So somebody uses SAS, but everybody talks about R now. Used to use SPSS, data visualization. Could use a refresher after being away from it for a while. Mostly use Stata now, but used to use R. Build your quantitative skills. Improve my data analysis skills. Like to know more in addition to Stata. So these are all great reasons. I used to be more of a Stata person, 6 or 7 years ago, I guess, or like even more, partly because I supported research, so that's what you would come. But yeah, I do more R now, just because of the research is kind of grown in that area, right? So I don't get as many Stata questions. So that's a real, and like, for instance, Jamie used to do mainframe SPSS, we still do SPSS, but we get more and more R questions. So those are all good reasons. It's free and good.
Actually, R can read and write SPSS data, a lot of different statistical packages, so it can interface back and forth with them if you have someone working with either of them.
Yes, thank you, Jamie. Very true. Yep, went back one more, and now we're going to open RStudio and get started. So I'm going to open my RStudio. If you can use your Finder or your Spotlight on Mac, or you can search for it. I'm going to have to open a new window. And when you open it, it will look like so. And you have it working right when it looks, I could clean this off, excuse me. When it looks like what I have. So let's get a thumbs up if you have this. And helpers, please let me see if, and if you don't have this, thumbs down or no, and we can help you get it. So what this is RStudio, and what it's telling you here, when you start it, it says, I'm going to start up this R engine, right? And I'm on 4.1.1 of R. RStudio requires that R is installed underneath it as the kind of engine. And if it's working, you'll see kind of what I have. Yeah, and Christian, thank you. He pasted an alternative. There's an RStudio in the cloud. that is run by the RStudio company. And that will let you do what we're doing here too.
So mine looks like that, but I then above it have like an untitled, like an area where it looks like you can enter text above the console. So the console terminal jobs thing is like the bottom half of my screen, and then I have it's like a split screen with the top level.
Yeah, that's cool. We're gonna get there. You're a little ahead of us. That's a script,
Oh, okay.
I think, in our script area. Or I'm thinking it might be. And that we're gonna be writing, we're gonna be using that a little bit. Are we all like ready to go? Okay. Yeah, let us know if you need some help. We can also, sometimes if you do need help, we can go into a breakout room. All right, so now you have our studio running. What I want your first step, I'll give you just a little tour. This is the console area. So this, you can run code here and work it out, and that will output the result down here in the console. We have an environment area, which this is where when we create our objects or variables, as you might call them, they'll show up here and it will kind of let us see what's in our environment. You can see there's a history that shows us all the commands that have been run. There's connections, something called tutorial. I haven't played with those. This is the files area, which will show you the files on your own computer, right? So this is my computer I'm looking at. You see something called packages. A viewer will be when we do plots. You'll see plots show. Sorry, not the view. Plots will be where we'll show plots. I use the help a bunch too, because you'll want to look up help for functions and other things we use in R. All right. The first thing I want you to do, it's kind of funny, I can't see, is I want you to go to the right over here. And there's multiple ways to do this. I want you to create a new project for this workshop. It might show you this. Do you want to save current workshop? Don't save because we haven't done anything yet. And then you'll get, can you see this pop-up new project wizard? So here we want to create a new project, and you want to put it somewhere. So I'm going to go ahead and go find my desktop and follow along. And I also have steps that I'll have you follow in just a second. And let's say intro R is what I want to create the working folder that I want this project to exist in. And then we create project. And what that will do, we'll start it, the project. And if you'll notice, then this is, I'm sorry, I had an existing, let me undo this, sorry. Ignore what I just did. Close project. I had an existing folder called intro to R. So I'm going to create a new project, step through this. I'm going to put it on the desktop. Call it intro R SS for social science. I'm going to create that project. And now you see I have a file pane here. It'll start this thing by name called intro RSS project, rproj. That's an R project file, which tells R, this is a project. It adds, ignore this get ignore, that I don't know why that got selected. I might have selected this to be a Git project, which is another integration, but we're not going to cover that. you notice here the file pane, here we're home, desktop, intro, RSS. So if you could, let me reduce this right now. If you could follow the steps that are in exercise 1 and hold your thumb up after you're done. So this is what we just did. So under file menu, I chose a different path. You can create a new project, create a new directory, click enter, and then you'll have that R project be created. One second, let me find my. Gotta find my R project. I think I closed it somehow. So you follow those steps and then give you a couple minutes and let me know. All right. So how are we doing? Doing good? All right, I want to show you another thing. Okay, I somehow closed my R instance there, what I just created, but I'll show you another benefit of that R project file that is created. So as you recall, I created this in RStudio, intro to R -SS R proj. So if I want to open R in this folder so it knows this project, I can double click this. And then it will open it. So it's set up, it knows it's a project, we're ready to go.
Tim, can you just go through creating a project one more time, the steps that you...
All right, so what I did, because I can't see my top menu because of my Zoom bar, I'm sorry. There's the other way to do this. So you can do it through the file menu, which is above my share, which is blocked. I could probably move this down a little bit. It's like,
Do you want me to do the steps with Windows? Because it will show, I think, my top line.
there's 2 ways to do it. So we can go to File, New Project, New Directory, New Project. You want to put, I just put it on desktop because it's easier to find, and you want to give it a name. I had to give it a intro RSS because I had an existing folder that had that same name that I wanted to use. And then you create project, and then it should open RStudio in that project, navigate your R to the folder that you created. So you're set up, you're scoped to go for the class. The second way you can do it, and somebody showed me last time I taught this for somebody in this class, you could do new project from this little thing right here, part of the RStudio window. New project, new directory, create the new directory name, right? Notice here there's things for existing directories. So if you created the directory already, there's something called for version control. If you want to pull people's code from GitHub down to your machine, which is a common thing. But here we chose a new directory. All right, Jamie, sorry.
In the chat, somebody asked, if you move your file from the desktop, will R be able to find it?
Your folder or your file?
This person said file, but I am wondering if they didn't mean folder.
That's what I meant.
Okay, thank you.
Yeah, see, the folder can move around. And it that is if it has an rproject .rporj file in there, that's what denotes a project. And then you double click that, it will open up RStudio, which is a nice convenience. All right, give me a sec, get back to my notes. One second. All right. Try not to lose my notes anymore. Okay, so we have created an R project. Now the next thing we want to do, and I think somebody already brought up that they had a pane above this console pane with something looks like a text file. We're going to do that now. We're in a new file, and we're going to call RScript. Okay. So now once you do that, it'd be file, new file, RScript. And they'll create this RScript file where we're going to edit and create we're going to create an RScript. So once you have that open, and hopefully everybody can get that open. We can do the second thing for project setup for this workshop. So we set up a project. Now, the other important thing about a project is we want to organize our project in a way that kind of makes sense. We want directories in our file area that kind of help us organize how we're going to do our work. And then we're going to get our data that we're going to use and put it into to our project. So to do that, we need to use a function, and a function is something that's like basically like a math function or other programming functions where it takes an input and it does something, right? So this function we're going to run is called dir, and dir stands for directory, and we're going to use create, right? And this will say I'm going to create a directory, and one thing we have common and often in many R projects is a folder called data. So type that out just like I have it. I think I have it in the Etherpad too. And we can paste it in if you need to know. But it's dir.create, open parens, quote, data, close quote, close paren. And to run our code, there's two ways to do it. You can do it via this menu here and click run. And you see what happened there? It created a data folder. Right. I'm going to create another folder. This one called data output, because often in our projects you'll want to have some, you mess with the data and you create some output of the data that you want to save. So let's run this. Instead of using this run, a shortcut is to use your command or control on Windows, command on Mac, and you do command enter on the Mac, and it will create a data output. Everybody there? All right, cool. So now we have a little project organization. I could create one, another one, and we'll be using mostly the data one, but I think we might get to the Fig output when Christian teaches data visualization in a couple weeks. And this will create one called Fig output, dir.create Fig output. And that'd be like your figures or your plots. So you see what we're doing here? We're going to be like doing this stuff in code. And when we create these objects, we're going to put them in these appropriate folders because otherwise it will get really messy quick. So this is good data practice. And then the most important thing is we want the data. Now the data is in a data repository called Figshare. And we're going to download file. So in R, you can also, in addition to creating folders or directories, you can also download files from the web into your project area. And this is, we can do it, you know, we could download it via the web, via your browser, and then drop it into this folder. But this is showing you how to do it in code. So this not only means you can do it in your current project, when you give it to somebody else, they'll basically, oh, I'll run these bits of code, I'll have folder structure set up, and I'll have my data downloaded, you know? So it becomes powerful so you can share the data. And it's HTTPS. And I think there's the code and the Etherpad. Let me know if there's not. So it's ndownloader.figshare.com. Figshare is a data repository, and it's 114.921.71. If somebody could paste that in. And then the second part is, so the first part is where you go get the data. The second part is what are you going to call it locally and where are you going to put it? And here we want to put it inside of a data folder, and we're going to call it Safi clean CSV. And then the last thing is the mode, which is like just kind of computer speak to make it writable, right? So it's like something that we just do. I don't have a good explanation for that. So that's, if we run this, and if I got my typing right, it's going to go to the internet and it's going to download our data file. We're looking here and there it is, right? RStudio is nice file, like you can look at files. I mean, we're going to do all this stuff in R too, but I could say, oh, let me view the file. Oh, it's a CSV. So I can see there's like a header for key ID, village, interview date, no mems, years live, respondent wall, and rooms and member association. So now we have data, right? And let us know if you've gotten that far. Give us a thumbs up. I can repeat that too if you need it. It's easier to paste it, to copy and paste on things involving URLs often, so we can do that. All right. All right, so we're set up. If everybody has reached that point, we have data, we have a folder structure that makes sense to us. We know where to put things, make things clean. Now we can get kind of busy actually learning R. So you did a lot of hard work there. So give yourself a hand. Congratulations. Often getting things set up is a very hard thing. All right, so R is basically when you work with R, you create objects. And an R object can be as little as something like this, like a math expression. So 3 + 5. And I can run that. And if you notice down at the bottom, by the way, is my text big enough? Hopefully that's a little better. Let me know if you can see that and if I need to go even larger. So 3 + 5. We get an error. Oh, I see a typo in there, Evelyn. HTTPS, not PPS. So like, just change it, yeah. So this math expression is also an R object. And it evaluates this, and it's a result. As I mentioned before, you can do a shortcut by doing Command Enter or Control Enter. You can also run it right here, right? We can also do division, any math you can think of, you can run in R. That results in like a floating point value here. But in order to do useful things, you need to save your object that you're working on. So then you can do other operations on it. So let's say we have an object called area hectares. And I want to use this funky thing here, less than dash. In R, that's called the assignment operator. And I'm going to assign 1 to it. This means it's basically, it's kind of like how it looks. You're going to take this value and assign it to what it's pointing at, which is area hectares. And we can run that. And if you notice what happens in the environment area, the values and the object appears and its value appears, which is really helpful. So you're going to learn to kind of like look at this area often. So the important thing to know here, this is the assignment operator in R. In other languages, they use equals, right? You see that a lot if you're familiar with other programming languages. Equals is okay in the R. You could use equals instead of that less than dash, but it's convention in the R community to use this assignment operator. So when you look for help, you'll see that. All right. All right, so we can assign a value to a variable. Notice it doesn't really print the let me see. So we're okay. So one thing you can do, and you'll go, okay, what's in this area hectares? I mean, like what's in this variable? And then you can run it by itself, right? You can type out the variable and run it, and it will show you in the console area what is in that variable. Does that make sense? So Sarah, area hectares means this is a variable or our object, and we're going to store a value in it of 1. So basically this means you can read this. I'm going to take 1.0 and assign it to this area hectares. And this variable now stores this number. And the second thing here is I'm going to print it out. So when I print it out by itself or use it like that, it's going to print it into the console. One thing to note, and I didn't really go over it, you can do R down here too, right? So if you want to work out bits of code in the console, that is listening for R commands too. But the benefit of this working in a script is you get to save it and you can run it over and over again. We can also do things, say I want to multiply area hectares by 2.47. So I'll go down here, I'll say 2.47 times area hectares. And then I'll run that, Command Enter, and then that will produce the result. Right. We could take that result and assign it to a new variable called area hectares. Area acres, excuse me. Right, so say I want to take 2.7 times area hectares and assign it to a new variable called area acres. (2.47 times area hectares. And we'll run that. And now it creates a new variable over here. You can see the value is 2.47, right? We can then, since to show you these variables are changeable, right? We can overwrite what's in area hectares with a new value, right? Now, if we print area hectares, that's 50. So what was in area hectares before was 1, but we overwrote it with 50. And this kind of illustrates that as you write these programs, these variables will change over time. So understanding what you do to them and then the change in their value is important when you're programming. One thing, okay, so one thing to note, and I haven't done it yet, but let's say we have area hectares and I assign it 1.0 again. I can comment my code, and this is really strongly advised to do. The pound sign, wherever you put the pound sign in R script, anything to the right of that will not be interpreted by R, and it's called a comment. So as you learn to program more and more, it's heavily advised that you comment your code so you know what it is. So I'll say land area in hectares. Right, and I can say area acres, area hectares times 2, excuse me, times, which is the asterisk 2.47. That's convert to acres. And then I can say area acres. Acres. And this would print out land area in acres. Right. So this one would, so you know which each of these commands, these operations do. And you can see when it prints it out into the console also carries that comment. Often, if you have a block of code, you'll comment the top part, what it does. You'll comment if you write a function. It's common to comment. This down a bit. So one helpful thing to know, RStudio also has a really helpful shortcut for commenting. So say if I wanted to comment this whole thing, I highlight it, I could do Control-Shift-C. And that will comment everything out. And I can do Control-Shift-C again, it will uncomment. It's really helpful if you're working through debugging a section of code. Like, oh, I don't want this to run because it's something's broken. I can comment it all out, fix stuff, and then uncomment. All right, that's great. So we learned how to create an object, save it. We learned what the assignment operator is. We learned how to multiply an object by another value, how to save that. We learned that these variables change over time in our program. So they're not like static. They just don't stay around as the value we initially assigned them as. So now we can explore some of the other features of R. And let's talk about functions. The functions are in R are canned scripts, you can think of them. So they do one thing, and they let us automate more complicated sets of commands. There are many functions in R, and many of them are predefined. They come with R when you install it. Some of them come when you install packages as well. And other thing to know about functions that often take an input, these inputs are called arguments. So a function will take an argument that's an input, then it will do something to it inside the function and return the result. So let's look at the function for square root. Say I do the square root function 25. What do you think the result of this will be? One? I saw you hold up a hand. 5. All right. Yes, exactly. So that will output 5. We have another function, round, 1, 4, 1, 5, 9. What do you think the output of this will be? 3, exactly. So this rounds to the nearest whole number, but that's not really what you want usually, right? So let's do a 3.14.159, and they have a digits argument that's part of round. And here, let's say I want, it's a 2 digits, my round, 3.14. Cool. So that's really helpful to know when you need to round things and you don't want to round to the whole number. So as we explore these functions, one thing it's really helpful to know is how to find help in R. Because I just told you, oh, there's a digit argument. You might have seen when I started to type that function that it popped up in RStudio to give me some help. But often you'll want to know, hey, how do I find out more help? So I have a little exercise. I want you to perform. It's in the Etherpad, but I can paste it into the chat as well. So type in your console, type in $round on the console, and then look at the output of the help pane. What other functions exist that are similar to round? How do you use the digits parameter in a round function? We just did that, so you've already answered that. So type $round at the console, and then type in some functions that are similar, because often a help page will give you functions that are similar to your round function. And just go ahead and type in the chat. Well, just like a couple of minutes. All right, any answers? Did you find the help? Yeah, trunk would be one. I never really used that one. So but that's great. Yeah, I think it's on that page. So to get there, you do have $round. This can be formed on any function, run on any function. And what's helpful here is that, yeah, the help is really helpful. Often they'll, at the bottom of the help, you'll get examples, which I always look for, but it will tell you there's ceiling, floor, trunk, round, sig, sign if. So ceiling will go up to the next round number, right? So, and I've used this before. There's cases when you'd want to use it. 1, 4, 1, 5, Right? And then I'll go up to 4, floor goes down 1. What does trunk do? 3.1.
Is that truncate?
Trunks to the nearest. Trunc takes a single numeric argument and returns a numeric vector containing the integers formed by the truncating the values of x towards 0. I don't really know what that means. Do you have any idea what that means? I mean, return the whole number, but is it expecting a vector? Yeah, okay, extra credit. Whoever figures out what trunc really does, besides return the whole value, let me know. But that's a good one. So ceiling, floor, trunk. And the main point here is use that question mark when you need to look and see what a function does, what arguments it takes. The other thing is helpful if you want to know the args. There's a function called args that you can run on the function. And it will tell you the signature for the function, which means what arguments it takes. So that's another helpful one if you need to kind of find out how to use functions. Every math function you could think of, most statistical functions, mean, median, mode, cosine, all those things are functions that are built into R. If you have a question, if you need to run some kind of math or something function, Google it. I'm sure it will be in R as a base function. And then when you install packages, they add more and more functions that you use. So understanding how to work with functions, getting help on functions is really critical in R. All right. Okay, so now let's get to the other the most kind of important data type or data, what am I thinking? Data object in R is a vector, right? Anybody have any idea what a vector is? Any thoughts? Have you heard of this word vector? List of data, awesome. Yes, in cells. That's very close. Yeah, so vector, when you're new to R, if you've explored other languages or things, you often hear of an array. You hear an array or a list in other languages, a collection of items. So vector is all of those things. And I'll go ahead and define one. So I'm going to create a vector called H8 members. I'm going to use my assignment operator. Remember this thing here? Less than dash. And I'm going to create a vector by using the C function. The C function it means combine and concatenate, I think. And what you do is you can put numbers or other objects like strings in there. Let's do 10, 6. And then when we run that, it creates a new variable. Let's type it out. Let's print it out. And print it out, you can see when it's outputted, you can see this number in brackets here. When you see that with a bunch of numbers, that really denotes it's a vector in R. These are often called atomic vectors, which are like the base data storage kind of unit in R. We're going to work with data in a bit, and data stored in R as data frame is a collection of vectors. Right? So a vector by itself, you think of it as a flat array. It's a flat collection of numbers. It can be characters. It can be other things. Right, so let's create another type of vector. Let's say respondent wall type. Let's do a C again. I'm going to do a quote, right? Let's see, mud daub. Because I want to save a character vector. And burnt bricks and sun bricks. So those are 3 wall types. And those are actually categories in our data that we're going to work with later. So this is going to create a vector called respondent wall type. And it's going to be a character vector because it contains character strings. So strings are a sequence of characters. So this is a numeric vector. Numeric vector. This is a character vector. Okay. So that's the basic, really quick study for what a vector is. So one thing to note, like, why do you think I quote these items in the C function? Any ideas? Yeah, that's one. They're not numeric valuable. Yeah, so they're character vectors. The other reason, if you don't quote them, so like say, yeah, they're not. Okay, I think y'all got at it. So if I don't quote them, R will think they're an object, right? Like R knows what numbers are and they're stored differently, but it would think this is like a variable, right? It would go look for it and it would have an error. So we're denoting that this is a character, it's a string. And so it tells R, hey, this is a string. You're going to store it differently as part of this vector. And so if we don't quote those, it will throw an error too. One thing you can do to vectors, you can say, hey, what's the class of this vector? And this is like inspecting. It says it's numeric. In our class of our respondent wall type.
Somebody asked if we can mix strings and numeric variables in one vector.
No. They have to be of the same type. Yeah, so I'm sorry. So it's like it's one of the peculiarities of R. It does enforce that. And it's really good because when we get to data frames are columns of vectors and they all need to be of the same type. And what happens when you try to do it? It will coerce those ones that are not the same type into the same type. So if you have a number, we could do it here. Well, let's say if we have a number, say this is 10, right? Or as a character. This will coerce this into a character vector. And let's print this out. See, now it's quoted. That's because R doesn't know, it's going to coerce because it doesn't know what to do with 10. Right? So it's going to say, let's make these all characters. It's a peculiarity. It will throw you in R when you do this kind of thing. It's unexpected. So that's like what's happening with R. Because, okay, these vectors have to be of the same type. You're throwing something, I don't know what to do with this quoted 10 with these numbers. So I'm going to make them all characters. That's the easiest way for me to deal with it. It's one thing when you read in data, if you do see things you don't expect, that's what probably might be going on. So something to be aware of. We're not going to go deep into that right now. The last thing I wanted to talk about, and then we can take a break, is doing some quick subsetting. So when you subset a vector, we use this bracket notation. Say I wanted HH members, I wanted the second element. This is the index for the second element. R starts with 1, unlike other programming languages when they index. And that will grab you 3, right? Say the responding wall type. What if I wanted sun bricks? If I do 3, that's the index for the third element in the vector, run that, it's going to bring back Sunbrooks, right? We could, what do you think happens if I do this? If I negate that? Goes in a circle. No, it'll return everything but, so it's an omission. Yeah, it gives you 1 and 2. Awesome. Thank you, Juan. The other thing you can do to note here, let's say we can do a range 1 to 2, right? And that will get us 1 to 2. So that's called a slice. We pull parts of the vector back. You could also do, let's say, one more thing you can do. Our C function is really handy in this context. So I can do C1, 3. Then we'll return those elements. So R is really, I love the fact that it starts at 1, and so the index are like, I know, okay, I get the first and third element, and I know what to do. The other thing to note, and then we'll take this last little bit, we want to go over real quick HH members. What do you think this will return? I want HH members greater than 5. This is a trick. Not a trick. You think it would, 10 and 6. But really what this is, a logical expression, is a conditional expression that returns a vector, a logical vector. Right? So at every place where that expression is true, it will return true. So the first is false, second is false, 2, 3, false, 10 is true, 6 is true, right? So we haven't covered that, but there's such a thing as called logical vectors. Logi vec, and say, let's create one. And we can show you how to get what we really want real quick. True, false, false. There probably is one. Let me think about, so this will create a logical vector. You see it's a logi, right? So to get what we want, like say I want only the ones that are greater than 5 in that vector, we have to know how to subset by a logical vector. So we have HH members, right? We have our bracket notation. What if I put logical vec, logi vec, forget what did I call it? Logi, I misspelled it. So what if I put that in there, which is this true, false, true? Then it would return the elements where those are true. And it did a weird thing that we won't cover because I get the wrong number of true and falses. Let me add one more. So true here. So it matches the length of our vector. We run this again. It'll give me 2 and 6. Right. Now we can use what we know from there. We can use a logical vector to filter, to subset another vector, right?
Got a question on the chat. Is there a function that tells you the position for elements that meet the condition?
Yeah, I think I answered. I didn't know. Sorry, but we can look. So now, and then we'll take a break right after this. So what if I do my expression HH members greater than 5 in here? Because we know this results in a logical vector of true and falses, right? False, false that's less than 5, true that's greater than 5. When you subset by that, it will return only the ones that are true. I still had 10 and 6 there. Does that make sense? It's a little confusing. I should have rerun this again. Rerun this. All right, so I saw somebody nodding their head. So it returns the one graded. This is powerful when we get to data frames because we know that we can create these conditional expressions that then when evaluated, return a true and false vector. We can use that in a subsetting operation for our data objects. It's like, I mean, it takes a little while to kind of get the feel for it, but I think we'll get there. I think it's like, which, okay, I didn't know that. All right, let's take a break. Do you want a 5-minute or a 10-minute break? 10 minutes, say up. Let's do 10 minutes. Then we'll come back. All right, so let's do it at 5:49 my time. Yeah, thank you, Christian. Stop share. Everybody stretch. All right, we're back. Hope you had a good break. All right, let's take a breath. We did so much. We learned what the assignment operator in R is. We learned how to create a variable or an object, how to do things to that variable and object. We learned what a vector is, a logical, character, and numeric vectors, and we learned how to subset them. That was pretty action-packed for like an hour and 15, 20 minutes there. So now we're going to jump into learning how to work with data. So we'll spend the next 40 minutes going over working with our data, which we downloaded at the beginning of this workshop. So let me go ahead. Is everybody, we're good with that? We're feeling good? Do we feel overwhelmed? I know we're cranking through this at a pretty good pace. So thanks for sticking with me. So let's go ahead and share the screen again. All right, we go back. Let me see if I can find my R. Just learn vectors. Now we'll need to, we're going to read in some data, but we need to do a couple things we haven't done yet. One is we need to install a package because we want to use that package by using this library function. So library tidyverse and library here, right? Library is a command that says, R, I want you to use this package. But before you use a package, you have to install it. Now, why do we have to do that? Because there's over probably near 20,000 packages now in R. And yeah, you have to explicitly install them. That means downloading it to your machine through RStudio or through code. And then you only tell R you want to use the packages you want to use. You want to clutter up your work environment. So if we go to our packages tab, click install, type in tidyverse, and then click install. I'll go ahead and do it. Okay, so that's going to go out. It's going to install the tidyverse. Now for me, that was really quick because it was already installed. And then I want to click install again and install something called here. And it will do the same thing. Yours is going to take a little longer if you haven't installed it. Because tidyverse is a big package and it needs, it's going to take a little while. Notice a couple of things in your package pane. There's an update function. Periodically, you should update your packages that you've installed. I haven't done it in a while, so. But yeah, the main thing is install, run this, and it will install the package. When you run library after you install it, so once you install it, it'll show up in this long list. And if you run library tidyverse or library here, and there's no error, you'll also see it be checked off over here. I have too many packages installed. So they're my here now, it's checked off. So what I mean is here, if you check off this, that's like running library. So they say, why do you want this in code? The reason why you want it in code, so you let your collaborators know that you're using this package. Once you get more skilled at writing scripts, typically you put all of the packages that you want to load at the top of the script. So it's like, oh, we're going to use all these packages and in the script. So let me know when your tidyverse is finished and we can move forward and load and read in the data. And while you do that, I'll just explain what we're doing. We're gonna read in this CSV we downloaded earlier as a data frame. This is the de facto data structure in R. And it represents tabular data. And really what it is, it's these columns of vectors. So each column in your tabular data will become a vector. And you can do to that column like what we've done to these vectors we've explored before the break. And just so you know, each vector has you need to have the same data type down the column and the same length. So those are some requirements. Why do you always do that? It's a simple image to show you that data frame. They have to be the same length, the same type. Right? Are we ready to read some data in? We have our packages installed, and now you've run the library on them, and they're ready to be used. All right, cool. And okay, one more note before we'll be using the SAFI, which stands for Studying African Farmer-Led Irrigation. It's a study that actually happened. This is a subset of that. This looks at farming and irrigation methods in Tanzania and Mozambique. And these were collected through interviews between November 2016 and 2017. Just to kind of give a sense of what this data contains. Do another column here. Right, so we have a village name, and the number, how many members in the household, how many years they lived at the village, the wall type, which we kind of created a vector earlier, the type of wall that their abodes are built out of, the number of rooms, if they're a member of an association for irrigation, the number of livestock, item zone. The item zone, there's a list of those. Jamie, when she does data wrangling, we'll learn how to deal with those multi-value variables next week, and so forth. So basically, this is a real data set to actually study in the field. All right, so now we want to import this into our environment. So first, we want to give it a name. So let's call it interviews. We use our assignment operator. And we're going to use a function called reCSV. Right, and it's going to get a little, we're going to do a couple things here. So I'm going to do read CSV. And what I want to do is type here, right? That's a function. Data. And then SAFI _ clean CSV. Now I'm doing that because here is a function that returns a path that will locate your data called SAFI clean.csv. Why are we doing this? Often in our projects, the path to things on your computer get really confusing, especially when you're sharing this with other people. So there's a notion of a working directory in R. It's a bit, it can be easily broken because depending on what computer you're working on and what the path is and what your directory structure is, things can get out of whack. So somebody created this helpful here package that helps us create a path that is then portable across different machines to your data or whatever object you want to use, right? So I'm going to put comment out there after that. And the second thing I'm going to do, I'm going to do NA null. And we didn't cover NA, but NA is basically there. It's a no value, right? It's like a null value. And why do you want to do that? Like, let's look at this data real quick before we read it in. If we look in here, we see these null values. That means there's no data collected for that interview, right? So by default, R will set that empty values to NA. That represents no value in R. NA does. So what we're telling R in this read CSV, that when you encounter a null, it's an NA. So set it as an NA for R. So then that will be actionable in R. So we're telling, hey, when you ever encounter a null and something called null in this data frame, the CSV, set it to an NA, right? You don't always have to do this. Say an empty cell, you have a CSV, R is pretty good with coding it to NA, but sometimes it will not. Sometimes no values are set to weird values. Like the census uses like 999 or something crazy, or used to, older census. So certain data sets will have weird null values. All right, so does this make sense? Maybe I should be explicit about what the here does. Say, let's do my here, and I'm going to do data. I'm going to run the code down below, Safi clean, right? So by itself, and I do this all the time when I have nested functions, I'll run them independently just to see what they return. So for me, that constructs a path to this data set, right? Does that make sense? And for you, that will be a different path. Say you're working with a collaborator, then that here would be relevant for them. So this gets around kind of broken paths is what it's designed to do. So let's run it, and I'll paste it. If you haven't been pasted into the chat, just so, well, let's make sure it works first. I'll run that. All right, so we create an interview. It's the code. Notice what happens up here. We have values down here, which are just like simple objects. Now we have a data. Unclick that. And data is signified by this little like data looking thing. Now you'll see the different variables that are in this data or objects. You also see it's 131 observations, 14 variables. The other cool thing in RStudio, you can click on it and it'll pop it up in a tab. It's all pretty. You can filter it, you can order it, to play with it. Can't really edit it, though I think there are packages that let you do that. But basically, you can explore the data. Right? You can also print it out here, which is something I would typically do. It'll print out a smaller, window of the data and the console. I often will look at it. I mean, that's kind of, oh, it didn't change? Yeah, it should look like NA like this. I don't know. I don't know what to say, Natasha. Maybe try, did you copy the code that I pasted? You
Oh,
did.
actually, it just worked when I look at it in the way you were and didn't open up the data set separately. So yeah, it works. Thank you.
Oh, that's a great point though, Natasha. Okay. All right. So if you looked at the data, like as you're viewing it here, this is the file, right? So this is what's on file, on your file structure. R is not going to change that unless they explicitly override it. When we read in the data, it becomes a data frame. which is an object in R. That's not affecting your file, the file, right? It's not going to change what the CSV is. We're manipulating the data in R. Hope that helps. All right, so we covered this read CSV will take a file, a CSV, comma, separated value. If you do look up more, so I didn't do it here, but say I started to type this, the autocomplete in RStudio is excellent. You can see there's many different other file types that will read. Table, TSV, which is tab, separated values, delimited, DIF, Fortran, fixed width file. So those other different formats you can read. We're reading CSV here. So Mia, that means we need to download the data into your data folder. Let me copy this. Try, if you're in your R project that we established earlier, you could run that. This expects, okay, yeah, cool. All right. So then after it's there, you should be able to run, load it. So now we have the data loaded. We can inspect it up here. I do this all the time. I go, what is this data? We can look at it in the tab. You can print it out below, right? There's other things that are pivotal when you work with data to know when you first read it in, like how you inspect it. Right? So when you inspect your data, you want to go, hey, what kind of class is this? We ran class on our vector. So this means it's a data frame, but it's a special type of data frame called a tibble, T-I-B-B-L-E. And that comes with the tidyverse. And it's just basically a different type of, it's something that works with the tidyverse. And the tidyverse is a set of a bunch of packages that work together. And we'll cover that more in the next workshops. The other thing you can do, and you'll often do once you get a data, somebody sent you data, interviews is dim for dimension, and that will print out, 131 rows, 14 columns. Also, it's common, hey, how many rows do I have? Just by itself, n rows get you that. There's an n calls too.
Tim,
yeah.
Can you just step through downloading and loading the interviews data? Like on line 54, you have interviews, so we're reading in the data, but can you post the download code on the line above that and just go through that sequence? Because a lot of folks were downloading it and it looks like it's there, but just to step through, download the file and then show where to look for it and then execute that second line just to confirm like things are working.
Also,
All right,
look in the files and make sure that you have the data folder, data output, and fig out. Make sure you have those folders created.
yeah, so this function, download.file, it's going to look at this URL, go grab that, what's at that URL, and what it needs in the second argument after the comma, it's going to put it in a data folder inside your project. So your data folder needs to show up like mine here for this to work. So if you don't have a data folder, that's what's missing. It's easy to create one though if you don't have one. If like you just create a new folder, type data, and add it. Then this code will work. So I'm going to run it. So this is download. I can paste it back again. download.file, open parentheses, the URL for the file, comma, and then where we want to put the file, what we want to call it, data/safi_clean.csv. The mode WB is like a write mode. And I never know how to explain that very well, but if we run it, it's going to go out. It's going to see down here, it's going to get trying that URL, and it's going to grab it, and it downloaded it. So it overwrote was here, and now there's a Safi clean in there. So you can confirm it's there by looking inside that data folder. Who doesn't have it? Who? You don't have the data?
I see the data in my files, but it's not responding to the finding the interviews. It's saying that does not exist. So I'm going to try to go back and recreate that directory or something. Yeah, exactly. Ariel, same thing for me.
Could it be because you're using, is OneDrive on the cloud?
Okay, thank you, Amanda. All right, let's type. Okay, let's see. So OneDrive. Yeah, the OneDrive might be.
I think if you can put it, if you can make sure it's on your machine, like put it in your, like, here, I'm gonna give you a path just for an example. Let me go pull up mine. It would look like, this is an example C, and I may be getting my backslashes wrong. C, users slash, this would be your name slash DESKTOP. Something, you're going to see something like that for Windows. So that would make sure that you're on your own desktop as opposed to being on OneDrive, I think is on the cloud. And we can get into a breakout room for Windows users if you want to walk through that.
All right, how many other people are having issues with that? Most people have the data. We could, Jamie, you could go in a breakout room and kind of
Sure.
get, I think there might be, I remember having troubles with the OneDrive before. I don't know exactly what the resolution is. You could put it on your desktop and try that.
Okay.
You know, like that's one thing if you want to move it, Jamie, to your desktop.
Yeah, let me,
So
okay.
go ahead
Oh,
and
different Jamie, sorry.
Ariel would like to join you too.
Okay, I'll go into a breakout room and assign manually. Okay, create.
Yeah, Christian has a possible solution.
Yeah, there seems to be a common problem. Like, so I don't have Windows, so I can't replicate it. But
Yeah,
I think that's an annoyance, and it's definitely not uncommon. It looks like just like a lot of other people on the web have the same problem where it looks like you have to update. Essentially, it wants to default to send the downloaded packages to a certain place, and you have to update R to say, "Hey, no, really send them over here." So if Jamie, you want to help out with that, and then I can
Sure, now-
I can
okay.
find an example of how to do it.
yeah, okay, I'll make a
Instead.
room and, let's see, there's, okay. And room one.
Sorry about that, guys.
Yeah, let's try this. Okay, room one.
And then we can, hopefully Jamie can get that, we can get that figured out, and then we can
Okay,
share the code that we're running while you're gone.
yeah, let me try this. Okay. Yes.
Sorry about that. All right, so, okay. Number of in columns is another thing you would look for. I don't know why. That's, oh, I'm not. Yes, thank you. And then calls. I'm always making little mistakes. So it's 14. Yes, I'm sorry. I like it's in calls, not an in call, not plural, which I have. So that'll give you the number of columns that you have. So what do you think head would do? Any ideas? Shows top 5. I think it's top 6, but yeah, you're right. Shows the top of your data frame. Head and other systems does different numbers, so I think head. So let's take head interviews. And what if I do 10 here after a comma? That's right. So it shows the top 10. So that changes the default behavior. It's an argument that will show whatever you put there. I can put 100 here, right? It'll show 100. So why do you think this would be helpful? Like say your data is really, you know, I mean, when you first load it, you want to kind of inspect what the top looks like, bottom. Maybe you don't want to, it's too large to kind of deal with effectively at one piece. So knowing the head and then the corollary tail, excuse me, is really helpful functions to work with. You see the bottom. Another one that's really good to know is names. And this will, what do you think this would do? Any ideas? What names would do? Names of the columns, right? So this is really important when you want to rename things. So names is a way to do that. We're not going to cover that tonight, but we can show you. But names is the names of your variables in your data frame. You can, it's a vector. So say I wanted the second name, which is village, pull that out independently, right? Can subset the names. So names is a vector and you can operate on it, which is important because sometimes the names you import in can be really unwieldy and you might want to mess with them. One of the most important ones you deal with is STR. So interviews, STR, which stands for structure. It gives you an output of the structure of your data. Or like, you know, basically it kind of looks like what we get when we win for all this. So basically it gives you the name of the variables, the dimensions, a little bit like the first few values in your each variable, the type it is, the length. And so it gives you a lot of like information in a compact way. So often when you read in a data frame, you'll use that. So let's look at summary, which would give summary stats on your variables in your columns. Run that. You can see it gives you the mean, median, mode, and the quartile range of each of your variables. Some are more useful than others because some are not numeric, you know, so they doesn't really work. But this gives you a sense of the shape of your data and the kind of distribution of some of your variables. All right, so we covered, let's do a bit of subsetting and then we can call it a night. So we have interviews. Say I want the first element, topmost left element in our data frame. I'm gonna do 1, bracket 1, and then 1 will be the topmost left, right? And that's like row and column. Gives you 1. You could change that to 5 and see what that will get you. It'll get you the element 4, right? So we can pick off however many of these you want. 1, 6. We do interviews. And to note, one thing to note here is this returns a data frame. Tibble. Tibble is the same thing as a data frame. So this returns the same object that you're working with. Say you wanted to get a vector instead. I don't want a data frame. I want a simple vector that I can do stuff with. So that's a common thing. You would do a double bracket here. And this will return the first column if you do it like this. So you can think of an onion, you're kind of unpeeling it. You have a data frame, which is a collection of vectors. If you double bracket it, I just want one of those. It's going to give me a single vector of the first column. You could do the same thing, but return a data frame, right? So that will be the same column, but it will be as a tibble. This sometimes in your code, you need different objects. So this gives you that flexibility. Let me jump ahead. One thing I wanted to show you. So if you look in these, when you're unfurl, you see this $sign, and you see it when we print out the str. $sign actually means something. It means you can use it to access a column. Right. Say I want all the villages. So this will return a vector of the villages, those each names. Interview 1 is showing us, oh, excuse me, the first column as a data frame. You can use invariably know you can use the $sign. Kind of this gives you a sense of what's accessible via the $sign. Any column in a data frame you can grab using that $sign. I didn't cover list in R, but there's a more complex object called a list, which is also addressable or retrievable via the $sign. A data frame is a list, but list we can cover in a different section. So just to know, yeah, that $sign lets you pull out vectors from a larger object like a data frame. And you'll do it all the time. I mean, you do need it. We had a whole day. Do you want to look at some data viz before we go, or would you like to? Because we're kind of at the end. I don't want to throw anything more at you. What do you think? Okay, all right. So let's do. All right. So one part of the tidyverse is a library called Ggplot 2. This will finish us today. Right? You can load it because you loaded the tidyverse. You might. So the tidyverse, when we loaded that, is a grouping of packages. It includes Ggplot 2. It includes the read, what contains the read underscore CSV. So it's a mega package. I'm going to explicitly load Ggplot 2. Ggplot 2 has a function called Ggplot. It takes in a data frame called interviews we'll use. And then what's weird, you have this sub function called aesthetic, AES. And this is how we map what's in our data frame to the plot we're going to create. Now here, I like to always look at kind of a histogram, distribution of a variable, a numeric variable. So I know there rooms is a variable. So number of rooms in an abode for the village. Right, and Ggplot, it's additive. So Ggplot itself, the function, we do a mapping, we say, take the rooms as the X value for the histogram, the X axis for the histogram. And then add to that, we're going to tell it how to plot it. And you have to explicitly say, I want this as a histogram. We run this, and it'll pop up. So there's my plot. You can see most people in the village have one room. Most. And then there's only one, like very few of an 8-room house. So that you can see that kind of distribution. Thank you, Christian. So you could do this for any numeric variable. Like you could change this out to years living in the village, which is another numeric value variable, and so forth. There's a few in the data frame. But let's do one more, and let's do like a box plot. And we can do a box plot of interviews, our data again. We're going to set our aesthetic X axis to, no, it doesn't. You explicitly save. So that's a great point, Jason. We would save this Ggplot as an object, and then we can write it as a, I'll show you a couple ways. But yeah, you can explicitly save it as an object. So use your assignment variable to save this output as an object, a variable in R, and then we can save that out as a file. There's another way to do it, and I'll show you just in a moment. So I'm going to do the respondent wall type of the houses, and then my Y is the number of rooms. So this is a box plot of those distributions. And I'm going to do a geom box plot, right? And I'll run this. And you see that gives us a nice, kind of number of rooms by the type of building, wall type. And you can see a distribution there. Like the mud dab, those are like 0. The rooms are mostly, or one room, or the mud daubs. And it's burnt bricks have more than one room, or can have 1 to more room, and sun bricks are used in 1 to 2 more. And so this gives you a sense of those variable distributions. Tell you one thing. One thing I like to do sometimes when I see something like this, I want to see a table of this. So there's a table function, which I use all the time. Respondent wall type by interview. Use $, rooms. This will give you an output of a table, like a frequency table. So you get a better sense of what the frequencies are with what you're plotting sometimes. And I think that's it for the night. We got 3 minutes left. How about questions before I can paste all this code in there, but you get a taste. Oh, your graphs don't show grid lines. Interesting. So the grid lines here on Ggplot, this is kind of a signature of Ggplot. And once you get more involved, when Christian shows you Ggplot, like we can show you like how you theme this. You remove those grid marks and you change the fonts, or you do different things, right? So this is highly configurable, and you invariably will change it. But when you see the grid lines, usually it's, oh, somebody was using Ggplot but didn't know how to remove them, or theme them. So it's like a signature for Ggplot. And that's it. I'll paste this last bit of code in there. If you come back next week, Jamie's going to cover more of manipulating data frames. And in the Etherpad, I put the link to the registration, if you haven't registered already, at the top. And then the following week, Christian's going to go more into Ggplot, like to do much more interesting stuff than I did. So at the top of the Etherpad, there'll be a list of the upcoming workshops and a link to the Zoom registration. Paste those in here. Any questions before we go? We got a minute. I'm sorry, running up against time. Any questions? Good. All right, thank you for coming.
Thank you so much.
Hope to see you next week.
Thanks a lot.
Thanks so much for your patience with the R and doing this all over Zoom.
Thank you.
We have 6 breakout rooms. Thank you for coming. Jamie, are you in the breakout room or are you? Oh, you're at 2 places. Oh, you came back and okay. We have 2 Jamies. So Jamie, did you get it figured out? I can't hear you. I'm sorry.
I said, sorry, I've got multiple screens going. No, I know what to do, but I haven't figured it out. It looked like my directory was pointing through Dropbox for some reason. So I think I know what to do to
And
fix
we'll get
that.
together, before the next class because I think OneDrive was one problem and then, going, we kind of got the idea and we'll get together on it before the next class.
Cool. So,
Yeah,
Yeah, OneDrive is evil.
I'm not on OneDrive, but yeah, I think it's doing the same thing where if you have anything else open like Dropbox or something, it's using that as your directory, whether you set it or not.
And then once you move the folder to someplace on your machine, you got to open the project file from that new one. So that'll make a difference.
Okay. All right. Well, thank you guys. You were wonderful. I've got to run and
Okay.
grab my toddlers, but I'll talk to you guys
all right,
later.
take
Thank you
care.
so
Thank
much.
you. Yeah.
Okay.
All right, bye.
Bye-bye.
I also just wanted to thank you guys, Professor Dennis. It was a really great class. I'm sorry that OneDrive, it turns out I just needed to disable it through the task manager. And once I had disabled it through the task manager, it all ended up working out. But thank you so much for your time and especially your patience.
Oh no, thank
Specifically.
you.
Yeah.
It's always these little things, we forget about. So thank you very much. Thanks
Write it
for
down.
persisting through it.
Yeah.
I would turn on my camera to say hello, but my cats chewed through my
Oh.
webcam. So I got
Oh.
3. I've got 3 of them, and they all hate wires. So.
Ouch.
It sounds like they want your attention. Quit looking at that.
Yeah, no, they're all here actually. They are literally all here just being like, oh, hello, mother. It's like, excuse me, where were you for the last hour? Like, where
Hey,
was
meal
my...
ticket.
Pay
It's
attention
true.
to me, not that camera.
It's true.
All right,
So,
thank you for coming. Yeah, and hopefully you'll come next week and we can get all this sussed out.
I'm very excited. I'm very excited. So
Yeah, just get a hold of me before the next class and we'll make sure you got that settled.
absolutely. Thank you so
Okay.
much, Jamie. All right.
All right.
Have a lovely night, guys.
You too.
I should write something down because